talk about price. I just give you a snapshot of the prices, and very important, these prices, of course, an average is just numbers that I took average on the business I see in many offers, and are for vehicles compliant with the safety standards, for example, in Europe or in the States. So hello everybody. Hello. Hope you can see me. Hope you can hear me. I'm here again for a new webinar, but today is a different webinar because it's not a sponsor. It's just a chat about mobile robotics, about the experience in mobile robotics, a general explanation about all the things that we regarding the mobile robot business, so the AGV AMR. I'm streaming on LinkedIn. Hopefully it's working. Please just write in the chat if it is working or not. Also, you have also the chatting click meeting as usual. You can write me there. Just please tell me where you are. If you can hear me. Billy, hello. Graham, hello. Fabian, always there. Thank you, everybody. Everybody's always, I see people every time there. That's this is great. So, well, let's start today. As I said, it's a quite informal webinar today. I'm going to explain you what are the main things that I see, and I need to explain to customers while approaching mobile robot business. Okay. Thank you, Christian. So let's start by talking about generally. But today there are many people that maybe do not know me very well. So my name is Alfredo Pastor. I'm in charge of content creation in AGV Network. I founded AGV Network some years ago, and I started to talk about mobile robots because my idea is to speak about mobile robots in order to make people understand what is behind a mobile robot business and a mobile robot project to help the adoption of this kind of vehicles. I've worked for 12 years in an integrator in Italy. It's called Movincar, a Prolis group. I have installed some hundreds of mobile robots from different suppliers with different technologies. So I have suffered everything in the mobile robot, from the navigation, from the charging, so from different, because seeing different technologies and different suppliers luckily helped me to understand many different things. So let's go into this webinar today, okay? First thing, okay? Today I want to explain you what is an AGV or what is an AMR. I'm going to say things that maybe seem to be quite obvious, but they are not. If you are the top king, top expert of mobile robotics, maybe this webinar is not for you. But let's stay with me, and maybe you find something interesting. So I'm going to say what is a mobile robot, what is an AGV, what is an AMR, the type of navigation, safety, very important things about safety, and the cost, mainly are charging strategies and cost. Okay, so very wide topics. Of course, each of these topics could have a dedicated webinar. Okay, so I cannot go into detail of all of them. So let's start understanding what is a mobile robot or a driverless vehicle. If we have to go we go to see the ISO. So whatever I can tell you, it doesn't matter. Let's talk about the ISO. So it's much easier and much competent people to say what is a driverless vehicle. So a driverless vehicle is whatever it moves alone by itself, but the safety does not depend on an operator. So the safety is integrated into the robot, and this is very important. If we go to see the definition between the difference of the definition of autonomous mobile robot and AGV, only from the theoretical point of view. If we go to the ISO 3691, which is the safety norm for mobile robots, we see that a driverless truck is whatever is called is an automated guided vehicle, is an autonomous mobile robot, is an automated car, is a cart, is a tunnel tagger, is an undercart. So it doesn't matter. Whatever moves alone is under that alone. I mean, by its own is under that norm. Okay, so this is what is saying the ISO. Of course, in the industry, we say AMR is fancy technology or autonomous behavior, whatever it is. I'm going to tell you my opinion. Maybe you agree or not. It doesn't matter, because if you do not agree, just write me, tell me, and maybe you convince me, okay? That we are here for that. We are here for speaking about this and just share some information. So mobile robot system. the first thing when I go to a customer and they ask me, I want a mobile robot or AGV or whatever, AMR, whatever it is, how much is it? What are the things that we have to consider? Okay, there are three main things. Okay, the robots, okay, the vehicles that are moving and are performing the missions. Okay, so physically moving pallets or whatever they move. We have a management system that is managing all the missions on the traffic, all the things we will see later on. And then we have a lot of peripherals, what I call peripherals, that are the charging stations, I don't know, PLCs to communicate with the conveyor, for example, or HMI for giving missions to the robots from a manual point of view. There are many other things that are always into this system, in this mobile robot system ecosystem, okay? And all of them are needed, not always, but are necessary to make the system work, okay? So as you see, I'm stay very, very high level, okay? Very general, just to explain you as if you were my customer or someone that is looking for mobile robots for the very first time, what are the different things? Let me talk for the first thing I want to talk before talking about the types of mobile robots, the safety, and those things that are more complex. What is the management system? The management system is typically a suite of software, okay, that we install in a host, in a computer, in a server, could be also cloud system, okay? So this is this brain, this software that is managing missions, the administration of transportation task, traffic, is creating reports about the performance of the vehicles, is creating alerts. You can see what the vehicles are doing, where they are. For doing this, you need some kind of graphical interface that are more or less developed by its supplier. And then into the management system, also we have to consider what is the communication between the robots and the system, because typically it's via Wi-Fi with the antennas or other things, okay? But this is more or less what is the main things that is doing the management system. Very important. One of the main things that are taking more and more importance today is the integration with other systems in the factory or in the warehouse of the customer. ERP, WMS, conveyors, elevators, palletizers, whatever. We need to integrate our mobile robots. The value that we are able to provide integrating mobile robots is higher if we are able to integrate with all these systems seamless, without problems, okay? Excuse me, without problems. So, because mobile robots today are not just go from A to B, from A to B. No, they are a tool to improve performance. They are integrated to the factory. I don't see them anymore as something like a logistics stuff, okay? It's more a production, it's inherent to the production. And for doing this, the management systems need to have a wide or as much as possible possibilities to integrate with different protocols, with different ways of communicate with all these exterior, okay, let's say external systems, REST API, VDA 5050, OPC UA, input-output, simple input-output with a PLC, very easy, okay? But it's very important that when you buy a mobile robot system, maybe from the very first beginning, you do not need all of these things, but it's important that you check that your supplier, whoever it is able to integrate with as much as possible of these different methods and protocols, okay? So this is the management system. So we have the vehicles, the management system that is controlling, and then other things that are out of the mobile robot, okay? So let's talk about the vehicles. What are the kinds of vehicles that we can find? Okay, we can find this kind of vehicles and this kind of vehicles. Typically, we have these categories of vehicles, which are the platforms, towing carts, okay, it's like a platform, taggers, tow tractors, and heavy-duty farmers. In fact, we have a lot of types, many other types. These are the more typical ones that we can see used in logistics and production. Also for sure the forklifts, but for the forklifts I have another slide. If we come back to these vehicles, I could have a webinar about only platforms, about towing carts. The platforms, they used to have some kind of lifting device, some kind of rollers, other things, okay, to pick the pallets, pick the trolleys, pick whatever. Of course, each system, each customer will need one type of vehicle, because all of these vehicles have some pros and some cons, some advantages and disadvantages. The towing cart is like a small tunnel tagger or tunnel AGV or mobile robot, okay, that has a pin, take a card and goes into the lines. Taggers, okay, just like a small tow tractor. Then we have tow tractors with the possibility to have them in automatic mode or autonomous mode and in manual mode. And then we have this world of heavy-duty platforms that are mainly customized and could reach up to 150 tons, okay? It's very complex for me now to speak about prices. I will, at the end of the webinar, I will give you some data because there are a huge array of different solutions from different suppliers. So it's very, very, very difficult. These are the main vehicles that we see today in the mobile robot business. If we go to the forklifts, nothing to invent. We have no invention in the mobile robot business because we just take the manual vehicles. We have the same kind of vehicles of manual. We have also in autonomous mode or automatic mode. So pallet jack, stacker, counterbalance, outrigger. Also, I didn't put here, but the outrigger, reach tracks, and very narrow aisle vehicles. Typically, pallet jack, we go up from 1 ton to 2 tons, okay? Stackers, more or less the same. Of course, there are cases with more capacity. I'm talking about average numbers. Counterbalance are more powerful. Maybe we can arrive to 4 tons, okay? Reach tracks, typically we have for 1 ton capacity, okay, or payload. And very narrow aisle, VNAs also very 1 ton more or less. If we talk about the lifting capacity of these vehicles, the pallet jack is floor to floor, so very useful for moving pallets from end of line, for example, so a buffer line in a buffer before delivery to a truck, for example, or opposite. Okay, when there is a truck is arriving, it's putting all the pallets on the floor, and you take your pallet jack and you go. This is a very easy vehicle because you can install quite easily because you do not need to adapt almost anything on your current flow. For example, if we had this with a kind of platform, or with a kind of with a platform, or with a towing cart, for example, with a platform, let's say that this is here, you should put some kind of docks, okay, to lift this pallet or whatever you are moving on these docks. With the pallet track, the pallet jack is easier. Of course, there are other disadvantages compared to platforms. They are bigger, so the footprint is bigger, so you need more space to do the maneuvers. They are more complex to put under the safety conditions because there are more. The shape is more complex. You need more device, more tools to make them safe. But this is a quite immediate vehicle to be implemented into a production site. The stacker is the same, okay, as the pallet jack, but you have the capacity to lift it, typically up to 2.5 meters, more or less. And the counterbalance, well, you arrive to 4 meters or even more. Reach tracks is one of the kings of the warehouse. It's one of the vehicles that I really love because they are compact. They can move in aisles of around 3 meters. Some suppliers even 2.9, 2.8, okay? And you can you can reach 9 meters, more or less, okay? There are also 14 meters, depending on the supplier, but this is the average, as I said. Very narrow aisles of 1.6 meters, so very, very narrow. Okay, these are like mammoths, very big outside the aisles. They are a disaster because they are huge, they are slow, but in the aisles they are the king of going up and down and putting pallets on both sides, okay, because you have the trilateral forks maybe, or the telescopic forks to do it bilateral, both sides. Talk about price. I just give you a snapshot of the prices, and very important, these prices, of course, on average are not from the suppliers that you can see in that pictures. These are numbers that I took average on the business I see in many offers, and are for vehicles compliant with the safety standards, for example, in Europe or in the States. So very important, because I have to say that you can find cheaper vehicles that do not comply with the standards, and we will talk about that later on, okay? So the pallet jack, on average, you could expect to pay 50,000 euro, more or less, 70, depending on on the battery. We will talk about also about that, depending on the supplier, on the safety scanners that you have, because you could have 1, 2, 3 obstacle detection, so depending, but on average, that is the average. Stackers, something more, because you have the lifting capacity. Counterbalance are more heavy vehicles and are more expensive, so around 90, but here counterbalance are a lot of different counterbalance, so you could have also counterbalance vehicles for 130, 20, 50, depends a lot. Reach tracks, this is more or less an average price, which is around 130, 150, 20, depending on the supplier, on the lifting capacity. So this is the price that we are seeing today in the market. And the VNAs, which is more complex vehicle, heavy duty, as I said, is roughly 200,000 euro. 180, 170, depending on the lifting, on the capacity, on the supplier. But this is at the very, and again, it's just average. So I'm seeing someone already writing, oh, my vehicle is cheaper, my vehicle, okay, I know, okay. Only, of course, if we comply with these safety standards. That is very important. I put it here. Let me, can you see this? Okay, the safety standards. I like this. I can write. Okay. Let's go with the next one. So these are the vehicles, the type of vehicles. Sorry if I cannot tell you more, because again, every vehicle is different. Every supplier has its own specifications, but these are more or less the average things that we can see. Please slow down, Marty. Okay, I will try to speak slower. Sorry. That's good. That's good. That is, I like that you tell me these things. What are the main components, main subsystems, okay, that we can find into the vehicle, okay? We have, on average, 5 systems, okay? On average, typically 5 systems. Maybe there are something more, but let's say about this one. Navigation system, so it's the system that is in charge of saying to the mobile robot where it is and where it's going. We can have a LiDAR navigation, 3D, 2D, magnetic system, whatever it is, visual, it doesn't matter. It's the navigation system. So it's the software and it's the devices that are used to for identifying where the mobile robot is and where it's going. The safety system, okay, is all the tools, all the system, all the safety devices that could be scanners, bumpers, radars, whatever it is, that are used for safety means. I mean, for avoiding going running into people, or if you go into someone, hopefully not, as less, let's say, harmful as possible. And this is the safety system. We have encoders, we have safety scanners. Okay, that is the PLC, of course, the safety PLC. We will see all of this. The power system. The power system is what is putting the power into the vehicle. So basically, it's the batteries and some electronic stuff that are into the vehicle. Of course, we have to consider also what are the peripheric stuff needed for that, like online charging or offline charging, in-progress charging, wireless charging. I talk about this later. So the power system. The motion system is what is moving the vehicle. So the motor could be a motor wheel, could be a differential drive, doesn't matter. So moving the vehicle in an horizontal way, okay? Could be forward, backwards, turning, jumping, flying. No, flying, no, of course. But okay, this is the moving the vehicle. And the lifting system, if we are talking about a mobile platform, for example, that has a lifting system, or a forklift. Also, they have a lifting system. There are pumps, hydraulic system, or whatever it is. So this is another system that I call the motion system, which is moving horizontal and vertical. And then there's the vehicle controller, that is the brain that is gathering all the information from the safety, from the navigation, from the power, from the motion, and is commanding the vehicle. Okay, there are suppliers for this thing. There are third-party suppliers, or there are suppliers that are AGV manufacturers that are developing their own controllers. It's a strategical choice. I'm not going to say which is better or which is worse, because it depends on the supplier. I mean, you would have a great supplier that is doing all the navigation, all the vehicle controller by its own. It's a great vehicle, perfect, marvelous, amazing. or it's a disaster. So on the other side, you could have another a supplier that is using third-party navigation or controllers and is not able to integrate into the vehicle. It's a disaster, or it's working perfectly. So please pay attention on these things, but I don't have to tell you this thing. I guess you can imagine. Okay, let's go into the navigation. Okay, we said the first thing that I told you this the AGVs has navigation systems. Today there are several types of navigation systems. The main navigation systems that we can see in the business today is the magnetic tape navigation, QR code navigations, laser triangulation, so laser guided vehicles, and natural. Natural, that could be SLAM, visual SLAM with LiDAR, 2D LiDAR, 3D LiDAR, it doesn't matter, natural SLAM. So what is the magnetic tape navigation? Let me show you a video, okay? Because maybe it's otherwise you get bored of seeing my face. And here it is. Okay, magnetic tape navigation is a very easy kind of navigation that you take a magnetic tape, you put it on the floor, and then the vehicle just follows this track and do some actions, some tasks, and given points that could be for example, with tags or with RFID, whatever. Okay, so this is the way. It's very easy to install. Okay, it's complex in the terms of you have a very complex installation with many curves, with many picking and dropping positions, with many things. It is time consuming. In other applications where the loop is not so complex, it's very easy because you can install 500 meters in just 1 hour, okay, because it's straight, everything is straight on, it's going forward, okay, and then some curves, etc. It's not so complex, okay, even if the people that, excuse me, my friends, is selling AMRs or natural navigation is saying that it's very tricky. It's not so tricky, honestly, okay? Depending on the application, of course. What are the disadvantages? Of course, there is maintenance on the track because in my experience, I have installed hundreds of kilometers, dozens of kilometers. And I can say that if you have a forklift that is doing the turning on the strip, okay, on the tape, maybe you have this problem. Otherwise, there is no problem. You can wash the floor and no problem, okay? So there is another problem, that is the cost of the tape. That is around $5 per meter, okay? No, per meter? No, yeah, per meter, $5 per meter. So it's not so huge amount of money. Anyway, it has its own advantages and disadvantages. One of the main advantages, of course, is the vehicle is relatively easy. So there is no big brains inside, and that is cheaper, and we will see when we see the cost of the vehicles. I will show you what is the difference between a mobile robot with natural navigation, a tow tractor like this, with magnetic and with natural. There is a very important difference. Again, when we will talk about the natural, I will tell you it's much more flexible, easy to install, easy to deploy, easy to then to change all the installation. Everything is true. QR code navigation. So you go with your QR code, you put a grid of QR code on the floor, and you give your vehicle all the missions, etc. In this case, the vehicle is following from one QR code to another, and then turns and go to another. It's the typical thing that we see in e-commerce, for example. In e-commerce is very used. All these Amazon systems, likewise, many of them are using QR codes. More or less the same problems that we have for the excuse me, for the magnetic tape. You need some maintenance of these codes because they can get wear, okay, but torn. But I mean, they are also cheap to install. Of course, you have to install thousands of these. Is time consuming. It's not easy, but again, the vehicle are much cheaper than with natural navigation. Okay, so this is the codes. Okay, let me see what is the next one, because I don't remember the video. You can see the vehicle is just 90 degrees moving from one QR code to the other. It's as I say, typical for the platforms. Okay, what is the next one? 1 second. I didn't remember, it was so low. Echo. Here is another one, reflector. So excuse me, this is the here. This is from 𝐀𝐿 Morgan. For example, is not as laser-guided navigation with reflectors. So you put reflectors on the floor, excuse me, on the wall or whatever you need, and the vehicle just makes this triangulation, calculates where it is, depending on what are the reflectors that they are seeing, so they know the distance to these at least three reflectors, the angle, and they know it knows where it is and where it's going. For example, I have here an application. You can see this vehicle. Excuse me. Okay, we can. If I again back. Okay, you can see here. There's the color here. No, but it's better if I put it red. Orange. Okay, here you have the safety. The navigation laser, and it's targeting these things. This is a reflector. This is a reflector. This is a reflector. This is a reflector. Okay, so you need to put these reflectors. The installation is quite easy, honestly, depending also how complex is the system, but it's not so complex. Then it's very accurate, very accurate, because we can reach tolerances of up to plus minus 1 millimeter even, okay, for the best systems. And for the economical point of view, I mean, all the things that you need to make these laser-guided vehicles work is more or less that you need for the AMR. So in terms of computing or in terms of sensors, so more or less is the same. They are more complex to change. Okay, you want to change the layout, the tracks, the missions. Maybe it's most complex compared to natural navigation that we will see, but it's more accurate. Then someone AMR or natural navigation supplier will tell me, no, mine is 1 millimeter or 2. Okay, but the average is around 10 millimeters. Okay, so it's 10 millimeters of accuracy compared to 1 or 2 millimeters of accuracy. This is the main difference between what are the different things of natural navigation today and what are the main, let's say, standards of laser navigation. And you will tell me, what do I have to install? I don't know. It depends on the project. It depends on what do you need. You need to see if you need accuracy, you need reliability, you need financially, you need something cheaper. It depends on your project. Okay. Okay. So I have to remove this. Okay, removed, and that is okay. Again, like here, you see here the reflector. But quite easy also. It's easy to install because everything is done. Most of the things are done during the project, so it's on the computer. When you arrive there, you have just to put the reflectors and then makes a calibration of the system. That's all. Okay. Okay. Remove this again. Oh, wonderful. Let's go ahead. After this, this is the laser navigation, as I was saying. Okay. What is the next one? Next navigation, please. I like this. This is natural navigation. Now we are going to talk about natural navigation. And in this case, we have these videos from 𝐀𝐿. You can see this vehicle that is moving in the factory. As you can see, there are not any reference. There are not tape on the floor. There are not reflectors. What it's doing is just simply watching the environment, is creating a map of the environment, and it's localizing itself in that map, and then it's navigating in that map. That simply and that complex, very complex. Okay, this is the concept. Is that this is what we call natural navigation. Under the natural navigation, we have a lot of technologies from the sensors, the algorithms that are managing all these things. Each supplier is different, so choose the right supplier. Okay, so as I said, the vehicle is moving, is creating a map. Okay, so this points red is what is seeing the vehicle. So this is the way. This way it knows where it is. Okay, this is another thing. This is like another kind of natural navigation, but using visual. Okay, so cameras. The concept is the same. It's just creating a map created with the cameras instead of the 2D LiDAR or 3D LiDAR. So it gives more data because, of course, a camera gives more data. It has other drawbacks like light conditions or other things, okay, or computing capacity to manage all this information. So, as I said, there is no worst or best, okay? Think about what you need. I'm going, please tell me. Okay, I finished. 1 second, I come back to the presentation. Okay, so this is what I was saying, okay? Can we have the slides? Yes. Those that are on Click Meeting, I will send in the thank you email. It's very easy. So as usual, if you are on LinkedIn, just I will put it on the write me and I will send it to you. No problem. It's free for everybody. I have no problem. So ask me the connection, and if we are not connected yet, then I will send you by personal message. Let's come back to the presentation, excuse me. Okay, so magnetic QR code, laser triangulation, and natural, what is called SLAM, okay? I said more or less what are the pros and cons. One of the natural navigation cons is that the reliability today in chaotic environments is lower compared to other systems, because if you have a map that is well defined for your system, that is watching the walls, is watching the cars, is watching whatever it is, the vehicle. If you change all of this, the vehicle could get lost because it doesn't understand what it's seeing. And this is a problem. But as I said, depends a lot also on your supplier. Okay, so it's the average issue is there, but it's not for everyone. There are ways to mitigate this. Okay, we can do sensor fusion, because there is not one single, in my opinion, one single technology that is the best. The best thing is to integrate several things. So the IMUs of the vehicle, maybe the SLAM navigation when you have to run far. Then maybe if you think that you are not confident, just put a stripe on the floor and then of magnetic stripe, and then you have a accurate docking. You can change from natural to laser triangulation whenever it's needed. But this is the power of your supplier. Okay, there are ones that are wonderful, there are others that are not so wonderful, and I'm not here to say names, but this is how it works. Okay, now this is the never-ending debate. What is an AGV? What is an AMR? This is my opinion, okay? But if you do not agree, just let me know. For me, it doesn't depend on the navigation, okay? You could have a AGV or an AMR that are with different navigation systems. Of course, the only thing that makes an AMR so autonomous, that is the behavior for me, is the only difference is that it's autonomous. The vehicle decides where to go. So it's not following a track. This track could be or virtual or physical, okay? So you could have programmed your system with all the tracks from a virtual point of view. You could have navigation, which is SLAM, visual SLAM. You could have laser triangulation, whatever it is virtual. But if your vehicle is following a line, it's AGV for me, okay? I call them mobile robots anyway, but okay, that's AGV for me. If your vehicle is able to decide the path by its own, that's an AMR. For doing that, of course, we agree you cannot do it with magnetic tape or quad code. Okay, you need to have natural navigation. Then, what kind of natural navigation? Again, is a discussion that we could have together. But so AMR is only if it's able to autonomously decide what to do. Okay. Otherwise, for me, is AGV. Let's go of them mobile robots. Let me show you another video about of course, AMRs have the capacity to do obstacle avoidance. And again, I'm not going to say here if this is good or not. It depends on the project. In some brownfields projects with small vehicles or with very well designed from the safety point of view vehicles, you could have obstacle avoidance. Other times it's risky. Depends on your supplier, on your project. Okay. I'm sorry, I'm not saying you anything. I'm just saying depends. But it's true. It depends. Look, this is an example of autonomous behavior. This is from Navitec. In this case, can you see the, okay. No, let's do right. Here it is. Red. Okay. Ecco. Here. Okay. Here, the vehicle is seeing this obstacle. Okay. Then here is seeing this obstacle. Here is seeing this obstacle, and the other one is here. This is another obstacle. Okay, the other obstacle. So what is the vehicle doing? Is he has to go from here to here. okay? Straightforward, but there were obstacles. So what is he doing? The vehicle is just deciding where to go, and is deciding where to go depending on what is seen in that specific moment. So it's autonomously able to decide what to do. This is an AMR for me. Not because of the navigation. It could have a visual system, it could have a SLAM, it could have 3D LiDAR, 2D LiDAR, doesn't matter. If you give me well, you cannot give me a magnetic tape navigation that is free to go where it goes. Sorry, it's not possible. Okay, let's go. Okay, let's go. So the vehicle is just correcting, is just deciding where to go. For example, it cannot go here because there is not a space enough to go. Maybe it's deciding to go here because it's the fastest way to reach this point, which is the destination point. In any case, it's deciding by its own what to do. This is nothing to do with the safety, okay? It's just navigation. The safety is not under the natural or autonomous behavior, because safety is dedicated, is a system apart of the navigation. Let me check. Presentation. Okay, let's go ahead. Okay, do you agree with me or not? Excuse me, because magnetic tape, okay? Magnetic tape, yes. Okay, well, I don't see people are saying that I'm not right, so that's fine. Okay, so okay, this is one of the main slides that I wanted to show you. Okay, there is not a best navigation supplier, as I told you. Excuse me, there is not a best navigation technology. Okay, you will have a best navigation supplier, because we can use all the suppliers could use the same sensors. Of course, choose suppliers with the premium brand sensors from navigation. But each supplier has its own algorithm, its own way to manage all the data that is receiving from the environment, from the sensor. So there is not you have to check what is doing your supplier. Okay, do not follow a technology. Do not follow I want to have a SLAM. I don't know. Follow the supplier. Go verify that the navigation is working in hard environments and harsh environments. The supplier has a good proven track of successful projects, and that's the way to choose the supplier and the navigation. Okay, because I said the capacity of the supplier to manage all this data are the same, but everyone is doing different things, and all of them are the behavior of different suppliers is completely different with the same structure of devices, tools, of sensors. Okay, so this is the one advice that I have to give you. Do we will go to you going let's talk about safety. Safety, again, we could have here a huge topic for a course for hundreds of hours, but let's try to think about the main things. Okay, here with this slide, what I want to show you is that the machine lifetime cycle starts from the design engineering of the vehicle, okay, the manufacturing, the installation and commissioning, the put it into service into a customer, operation, modification of the AGV system or mobile robot system, and the decommissioning. And all this product life, there are responsibilities from the manufacturer, from the integrator, for the end user. So, of course, the machine has to be designed and built under given conditions. For doing this, we have to follow the standards. There is no way. There are the standards that are telling us how should the machine be to be as less risky as possible, because mobile robots are risky. Okay, they are not safe 100%, but let's try to make them as less risky as possible. Then we have to do a risk assessment on the environment, okay, when we go to install them. And then we have to follow periodically the safety status of the system, okay? And this can be done with the end user, which has its own responsibility, because each time an end user is introducing a new risk, and a mobile robot is a new risk into the working environment, the end user is responsible for the people that is working in the factory, okay? So liability is everywhere. In this case, I want to show you. I have an extract from the ANSI RIA 15.8.2. Okay, that is very clearly specifying what is the specified operating environment, so the SOE, and the deployed operating environment, DOE. So because the manufacturer is manufacturing a mobile robot, is doing in Europe the CE certification on the machinery's regulation in the future. We will talk about this under given a specification. So payload, flatness of the floor, speed, luminosity, whatever it is, okay, under given conditions. So with these conditions, the vehicle, if it's following all the standards, all the rules, is safe, okay. When we install into a project, into a factory, the conditions could change, typically change. Okay, so this is what is the deployed operating environment. The deployed operating environment are these conditions that could be different from the specified operating environment. And in that case, the integrator or the end user or all together, they need to mitigate potential risk because maybe there's dust on the environment, then the sensors are not working properly. Maybe there is a slippery floor because there is water, okay? The supplier maybe did not test the water on the floor because it's a standard pallet jack and it's not a specifically designed for this kind of floor. So the integrator, the installer, has to modify some parameters, for example, of the safety fields or other things, I don't know, to mitigate this risk. So this is very important because if you buy a mobile robot which is CE certified or ISO certified or ANSI certified, it doesn't matter. You have to go also into the environment, okay? It doesn't matter. Excuse me. You must buy, but you must also check that then is installed properly. So, and what are the main standards that we see today in the mobile robot business? There are quite two worlds, okay, in the States. We have several bodies, okay, bodies that are involved in the safety. So the OSHA, the ANSI, some fire and other things. Also, it's more complex because there are also dependency on several federal regulations, but mainly all the mobile robots are following, for example, the B11.0 for the risk assessment, or the ANSI RIA 15.8 for the industrial mobile robots, okay? So, or the B56.5 for the automatic guided vehicles. This is the differentiation in the States. But in any case, if you are in the States, you are buying a mobile robot, buy this with these specifications, okay? In Europe, we have the machinery directive that is going to become the machinery regulation in 2027, and we are following more the ISO standard, so the 3691 for 2023 that is now under review. So why is important to buy mobile robots with this standard? For example, in this specific case, the ISO 3691/4, because the 3691 is a C-type standard, so it's a standard that is specifically designed for mobile robots, okay? I call mobile robots. It's taking the whole vehicle into consideration. Then we have the Type B standards. The Type B standards are standards that talk about specific devices. For example, they tell you how should be the safety scanner, the E button, the bumper, okay? And then we have the general standards like the 12,100, that is the risk assessment. If you buy a mobile robot that is compliant with the 3691, you are inherently assuming that all the other standards or all the other things are under control, okay? Everything is done by the book. So this is why very, very important. Then there's another thing to say that even if you buy a mobile robot that is following the standard, it doesn't mean that it's 100% safe, because, for example, the 3691 does not tell you how many safety scanners you need to put, okay? And maybe you have a risk because you have some kind of hanging object, and you need some safety scanner to detect this, for example. So again, first, I will tell you later, but buy suppliers that are compliant with the standards. Very, very important. Then check who is your supplier, of course. Let me just show you another video. Okay, very general video. In this case, it's from 𝐀𝐿, just to show you. This is very general. You know, if you are already know about mobile robots, maybe it's this obvious, but it's important because not everybody is aware of this. How does the mobile robot system work? Excuse me. Safety. In the mobile robot, we have safety scanner, safety encoder, safety PLC, many safety things that are safety rated. It means if a device is safety rated, it gives you a certain probability of failure, okay? So if it is safety rated with a PLD, for example, it's saying you that the possibility to have a failure is very low over, I don't know, 10 years, I don't remember. You can check in Google. So the point is that all these standards are saying how should be the safety rating of each component, okay? The braking, the scanner, the bumper, the relay, the encoder, okay, the PLC. And it's very important that there is a safety chain that must be respected. It starts, for example, this scanner is detecting a person, okay, is giving safely the information to the encoder, so excuse me, to the PLC, that is safely stopping the vehicle. So all this has to be done in a safety loop. Very important, okay? So check this when you are buying a mobile robot. This is a wide explanation. So the safety encoder is giving you what is the turning position of the vehicle, what is the speed of the vehicle, so you can program the laser scanner longer or shorter, depending on the speed, depending on the load. This is done by the book, okay? And typically we have 2 or 3 safety fields that we call warning field. Excuse me, guys, stop. Okay, warning. It means that the vehicle is detecting someone or something, is slowing down, and then we go into the red zone, which is stopping the vehicle. The red zone is the only that is considered in the standard, okay? The other things are just to allow the vehicle to go slow down, it's fine, but the red zone is the only thing that you have to check. Is the only one that is considered in the standard, that's all. So the vehicle has to stop before touching anyone. The safety scanners, you can have several safety scanners because you should cover all the movement of the vehicle. So when it's turning, when it's going forward, when it's going backwards, and for doing this, the safety scanners, you can configure the safety scanners with different shapes. You can have look, here it is, perfect. In this case, for example, is turning, so it's opening this side of the safety, this side of the safety, is opening this side of the safety, is changing the shape of the safety range, okay, to detect if there is someone or something. Okay. In this case, there is a guy there. I don't know why he did not realize there is a vehicle going to it, but in any case, the safety scanner is detecting the person, so it stops. Very, very simple. Of course, there is a huge amount of information behind this that we could discuss for hours and hours and hours. Okay, let's come back to the presentation. Okay, where I am. Okay, I talked about the vehicle. The environment is not as important, but as more important. No, it's important the same, because you have your vehicle, as I told you, but it's not said that you are installing it in a proper way. Okay, for doing this, there is also the standards. The standards in this case are giving guidelines of how to install mobile robots. For example, the 3691 has identified several zones of operation for the mobile robots, depending on several factors like the speed of the vehicle, the presence of safety scanner, the presence of emergency button, the presence of the clearances, the space between the person and the fixes the structure. So when there is some kind of pinch point, no, these distances, these clearances, okay, these gaps, we could identify different types of operating zones. We could have operating zones that is operating, so no risk or lower risk, let's say. The vehicle maybe could run faster because there is open, you cannot pinch anyone, so that's fine. Maybe we have operating hazard zones, so more restricted areas, restricted zones, confined zones, and low transfer zones. Just to give you an idea, because I cannot go into detail of each of them, what it's saying, because this is written in the standard. An operating hazard zone is a zone, for example, of inadequate clearance, and you have to design it operating as a zone. What does it mean? It means that you go to your factory with your layout and you define each point of the track of the vehicle. You define what type of operation of safety zone it is. Is operating or is hazard? If it is hazard or if it's whatever it is, you have to put under other measures, other means to reduce the risk. For example, you have to limit the track of the speed. You have to make the vehicle beep, 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 sound alarm. You have to mark the floor. You have to put a big cartel saying, warning, vehicle, AGV, automatic, whatever it is. So that is the things. And all these zones have their own specifications. So in the standards, these are written. And when you install your mobile robots, you have to do this. It's mandatory risk assessment on the environment. Okay, that's very important and well done. Because not everybody is doing, sorry to say, and I see problems. And the main problems that we have in the mobile robot business today is because on the environment, not of the vehicle, okay? On the environment, typically. But well, I show you this. 1 second. This, for example. I have created, for example, this is a kind of infograph explaining what are the different types of zones, confined zone, restricted zone. You can download it then in AGV Network. I will show you how. Come back to the presentation. Sorry, but I have a lot of things to say, as you can see. It's very hard because, but let's make a summary of safety, okay? First thing that I have to tell you, if you are an end user, if you are an integrator, if you are a manufacturer, even more, buy and understand the standards. You have to buy them, go to the ISO online shop or the ANSI or the A3 or whatever, buy them, read them, understand them. If you don't understand them, ask people maybe that is understanding it. You have to understand them because it's very important. If you are the end user or the integrator, you are in any case liable at a given point, responsible, let's say. Always do environmental risk assessment, okay? Is king, okay? You cannot put a mobile robot with an environmental risk assessment following the B11.0 or the 2100, whatever you want, but you have to do this environmental risk assessment. And very important, communication between people, okay? Because all the stakeholders, maintenance people, operators in the factory, integrators, even the people cleaning the floor in the factory must know there is an automated vehicle, how does it behave, how does it, what are the safety measures, everything, okay? So communication is a must. It's very, very important. Many problems, we should avoid many problems if we just communicate properly between all the stakeholders. My advice is buy only vehicles which are compliant with safety standards, because if you don't do that, and there are a lot of, okay, you can buy because, for example, in Europe, you have a CE mark. This is what I'm saying, excuse me. The mobile robot safety standards are not mandatory, okay? So you can sell a mobile robot in Europe, for example, that is CE mark, but it's not the 3691, okay? You can do that, but if you buy that, in case of accident, you have to justify why you are not following the standard, and you have to justify that your vehicle is even safer. So it's better if you buy the vehicle that is already with the standard, okay? Also because honestly, this is the robustness of the supplier, the commitment with safety, if they are following the standards, okay? That's very easy. So choose a supplier with a solid track record in functional safety, okay? You have better quality, safer environment, everybody's more happy, okay? Unluckily, we see later from the economical point of view, of course, not being compliant with the safety standards could lead to cheaper vehicles, and that's a problem because cheaper vehicles, more risky vehicles, but this is just an opinion. Okay, now let's talk about batteries. What are the main batteries that we have in the mobile robot business? Lithium, that today are the best, the most used, and in the past they were very expensive, complex to manage, but now almost everyone is using lithium batteries because even they are let's say, expensive when you buy them, because if you see here in my table, you buy around 800 euro per kilowatt, compared with other kind of batteries like the gel or the open lead acid or AGM batteries. But all the features, all the characteristics of these batteries are much better day and day. Of course, you have budget limitations. You do not always need the lithium battery. So we have lithium batteries, we have gel batteries, we have fluided lead batteries, acid lead, and AGM batteries, which is called pure lead batteries, something like this. Here you have the difference in terms of pricing. What is the DOD? Why I say that the lithium is better today? Okay, because this is a very important factor. The DOD. The DOD, the depth of discharge, is the amount of discharge that you can do on the battery without compromising the life of this battery. For example, you have I put numbers: 100 kilowatt, 100 battery. You can if it is lithium, you can discharge up to 20 and go back to 100, go to 20 or to 100 without compromising the life of the battery, or at least less. Okay, other batteries you can have also 40%, 50%. It means that if you have 100, in fact you can only use 100, you have only 50. Okay, because if you go further, maybe you make a problem or you have a problem with the battery. And this is very important. It's linked to the cycle life. If I show you this graph, for example, if the lithium battery, if you go for a deep of discharge of 60%, you have around 4,500 cycles. It means that your battery will last for 4,500 times from 60 to 100. If we go to gel, only 1,250. So the lifespan, the usage that you can get, the amount of kilowatts you can get at the end of the life of the battery is much lower in the gel battery and other batteries compared with the lithium. Of course, you pay 800 euro per kilowatt in a lithium, or you pay 200 in the gel. Depends. This is very linked to the charging strategy. Okay, that we will show later. Another important thing is the C rate, so the C rate factor, okay, the charging factor, that is the amount of energy that you can put into the battery, again, without creating problems. For the lithium, you can use 1C or 1.5. It means that you have 1 kilowatt battery, you can put into that battery 1 kilowatt in 1 hour, okay, so it's very fast, and you don't have a problem with the battery. With the gel, if you have a 1 kilowatt battery, in 1 hour you can only put 300 watt, okay, 0.3 kilowatt. So for fast charging is not a solution. So today we know we go into the offline charging, so opportunity charging, in progress charging. So this is why, because you need to improve the availability of the vehicle. So this is why the lithium is taking more and more importance in the business. But I will show you again, in some cases, maybe you do not need the lithium, because depend on your project again. It's almost 1 hour and I have to say many things. Guys, if you have to leave. Otherwise, you just I can send you the presentation. Okay, what are the charging strategies? I thought it was gonna be faster, but battery swap, online charging or offline charging. Someone told me no, it's offline because the vehicles go to a dedicated area and they go charging. In process charging, so whenever you have a vehicle that is into the process, okay, for example, it's going, I show you, it's better if I show you. And then the wireless charging, that is a subtype of technology used for the in-process or online charging. I show you a video, okay, battery charging, okay. For example, this is what we say offline charging. The vehicle is doing charging by its own, that's fine, but is doing whenever it has idle time. So it has no missions and it goes to charging, to the charging position. It does the charging, etc. It can be done with wireless charging, with contact charging, it doesn't matter, but it's out of the process, okay, offline. The vehicle is going by itself, okay, so the operator does not need to take care about it, but it has to be free, the vehicle. On the other hand, we have another technology, which is the progress charging. So the vehicle is doing the charging into the process of the mission. Okay, in this case, for example, the AGV or the mobile robot has to go to a conveyor, and there is the charging station there. In this case, it's a wireless charging. It's a video from 𝐻𝐻, and is doing this, performing this charging. For example, why I'm showing this, because in this kind of processes, the wireless charging is faster because you don't need to wait the contacts to touch, so the flow of energy is immediately, okay, and the charging is much faster in this case. So the AGV is charging, the mobile robot is charging in the process. Then we have okay, you can see in this case it's wireless, so there are 2 coils, and it's doing by induction. There are other technologies, so the battery exchange, but it's very expensive if it is automatic, because well, this kind of device costs more than a vehicle. But it's very interesting because if you have the payback on that, the important thing is that your vehicle will have always time to work, because the battery exchange needs around 2-3 minutes, and then you have maybe one shift of work for the vehicle that never need to stop. So you have to think about the battery. It will work. You have almost 100% availability of the vehicle. Of course, you need a second battery. You need this charging station. You need the exchanging machine. You can do also the battery swap manually, but of course you need a person. You need to have the labor cost on that, and then it becomes depends on the project. What other solution do we have? Yeah, okay, this is changing the battery. Okay, and okay, I wanted to show you this because this is a new technology. It's from 𝐀𝐆𝐵. It's a company that is producing in-motion charging. So there is a mat on the floor, and the vehicle goes on that floor and is charging while it's moving. So it's a step forward of the in-process charging. So it's another way of course, it's not for all the flows, it's not for all the vehicles, but it's another possibility. Okay, you can see there the vehicle that is performing this charging while it is moving. That is quite innovative. What else? Good. Okay, let's come back to the presentation. Okay, well, I cannot go into detail of all these things now because there is no time. I can show you later. Cost. 1 hour and a half not said anything about cost. I'm sorry. Cost. Here we have what are the main advantages of mobile robots compared to manual forklifts or to auto-managed vehicles. There are well, avoid mistake, improves traceability, more safe, better ergonomics, because if the vehicle is going in cold condition, you have the person that is going in the cold area. Vehicles are last longer because they run smooth. Okay, there are a lot of indirect costs that are very complex to evaluate into a spreadsheet. Okay. But if we go to see what are the direct costs, if we compare, for example, forklifts with manual forklifts and automated or autonomous forklifts, of course, you have in the manual, you have the salary of the people that is driving the driver. The forklift cost is the number of shifts is very important, because the number of shifts will give you the number of persons, and so the labor cost, the number of vehicles, and the maintenance. If we go to the direct cost of the mobile robots, of course, the AGV vehicle, that is higher than the manual vehicle, that's clear. The number of vehicles that tends to be higher than the manual vehicles, okay, because like it or not, they are typically slower. There is the management software that I told you before, this brain, no, that there's a cost on that. The installation and commissioning, that is another cost, and the maintenance, that more or less is the same as the manual vehicles. So what are the main cost drivers that we see in a mobile robot project? So the number and the type of vehicles, the characteristics of the vehicles, of course, installation and commissioning cost, so everything that is labor cost, so in the engineer that is going there to program the vehicle and is going to make the test, etc. The maintenance, well, this is okay. The software cost. This brain has a cost depending on the supplier, depending on the complexity of the system, and other additional costs like transportation, training, documentation that I will show you. if we go to see what are the cost of the vehicles, for example, depends on the type of the vehicle. For example, the forklift, the tugger, the platform is clear, has different cost. Typically, the main drivers are the payload. If we have a lifting device like a forklift, also the lifting capacity, the battery, because the battery we saw you, the forklift, the lithium has a cost. The other type of batteries has have another cost. Of course, for the initial investment, because then if you consider the total cost of ownership, maybe the cost change. And the navigation method. The navigation method also is a question of is a cost. Depends on the vehicle. The number of vehicles, of course, is a cost, because the number of vehicles of mobile robots, as I said, are typically lower than the if you take a manual forklift system with 2 vehicles, you probably need 3 automated guided vehicles. The average is 1.5 automated forklift compared to the manual. Okay, if you have 10, you will need 13, 15 automated guided vehicles. That is the rule, more or less. Okay, the number of vehicles depend on the speed of the vehicle. Sorry, this is not great engineering. The charging solution, because if you are able to do in-process charging, or you have manual battery swap or whatever, it takes time of the capacity of the vehicle to make emissions. The quantity of units lost, of course, if you okay. In this case, for example, considering that these vehicles, for example, a mobile robot is running at 2 meters per second, that is very fast. But when it's doing the maneuvers, the curves, the checking, controlling, etc., are slower than manual vehicles, so than humans. Of course, they are safer. So if the layout is very complex, typically you need more vehicles, more automated guided vehicles or autonomous vehicles. The pick and drop positions also define what are the number of vehicles, because of course this is in the floor or this is 9 meters, the time needed is different. And the number of missions that we use to calculate number of missions per hour. So with all these elements into a calculation, you can decide how many vehicles do you need. What else? If we go to the cost of the mobile robots, of the forklifts, a pallet jack, more or less, as I said, is around 60,000 euro, 40, 50, depending on the supplier, depending on the safety. The forklift, as I told you, around 90, reach tracks 130, and very narrow aisles 180, more or less. Okay, it depends on the payload, on the stacking height. Not depends on the navigation, because if it is or autonomous or is automated, it doesn't matter, because the sensors are the same, the capacity of programming is the same. So if we are talking about tow tractors, for example, here the navigation method is important, because you can have one tow tractor of 1 ton, which is magnetic, around 20,000 euro, 18,000 euro. If you have a natural navigation, is 30,000 euro, more or less. Of course, installing that natural navigation, which will be much easier, lower cost on that. So at the end of the day, you have to check what is the total cost of the system, not of the vehicle. You have 10,000 euro difference here, and you have 10 vehicles, you have 100,000 euro difference between the 2 systems. Okay, is this cost compensating the lack of flexibility, the other installation cost? Yes or no? I don't know. Depends on your project. Other things. What else? Platforms. Tow tractor platforms. Again, depending on the cinematics of the platform, if differential is unidirectional, bidirectional, depends more or less what are the costs of the vehicles. Here again, you have a magnetic tape navigation. The vehicle, for example, if it is unidirectional, maybe it's cost 14, 15, 16,000 euro. If it is natural navigation, which you need, and you need this one, okay, you need more sensors, more capacity, more then the vehicle is more expensive. Then, but again, easier to install, is more flexible, more advanced. Okay, depends on what is your needs. What are your needs? So if we talk about the software of the system, what is the cost of the system? Here, this is completely different from supplier to supplier to project to project, but you can spend nothing because if it is very stupid system that is going from A to B, or you can spend up to 100,000, 150,000 euros if you are implementing protocols of communication with a WMS, if you are installing a WMS, if you have a huge amount of pick and drop positions, you have to install to program all of them, all the conditions, so all the traffic depend on the complexity. On average, you can spend, you can expect to spend 40, 50,000 euro more or less. Okay. Installation and commissioning. This is all the cost that you have for the people that is in the factory installing the vehicles. Depends on the number of vehicles, depends on the complexity of the installation, and depends again of the integration with other systems. Depends on in this case, depends on the navigation, because as I said, you have to install a natural navigation pallet jack, natural navigation tagger tow tractor, for example. It's you guys just go into the tow tractor, drive, map the environment, and it's done. You have to do with the magnetic tape. If it is a complex circuit, maybe that's not compensating the difference on the cost. Okay, depends again on the cost. And then there is a lot of other costs that we suppliers of mobile robots love to ask: transportation, project management, factory acceptance test. Excuse me, there's twice, it's the same. Environmental risk assessment, what I told you, you have to do the environmental risk assessment, but you have to pay for that, it's clear. The training, the project documentation, the advisory, even there are suppliers that even only for giving you a price is asking you money. So what, this is, everybody's different, so ask your supplier, because all these numbers that I have given you are completely different from supplier to supplier, and the world is wonderful because it's full of different people. So hope you have enjoyed them. If you want to download the presentation, as I told you, just write me a DM me on LinkedIn. I will send you the presentation, no problem. If you want to download I just ask you to go to AGV network to download, to register, and to download all the documentation that we have there, because there are Excel cost calculation, there are white papers, there are infographics, a lot of things, all for free. Just you have go the register and you can see everything. And then this was my first webinar like this, just to speak, and I wanted to know if you would like to have another webinar, and in case hopefully yes, or maybe not, yes, tell me, do you want to speak more about safety, more about cost calculation, or a specific webinar on my advice on how to choose and select a mobile robot supplier, and very specific things that I used to see and to check when I'm choosing them. So sorry, but today there is no time for questions, but I mean, it's very general, as I told you. So you have questions, just write me. If I can, I will answer. If I can't answer because I do not know, I will ask someone else that is much clever than me. I don't, no problem. So for me, that's all. Thank you, everybody, for being here today, for participating to this webinar. And let me check how it's doing the. Okay. Thank you, everybody. Thank you. It's a real pleasure. Let's stay in touch. Bye-bye.